Hey, in this video, let us discuss the concept of Hess Law and the problems relating to Hess Law. Say Hess Law is very simple. Suppose you have a multi-step reaction. Okay, say here one example is this: A plus 2B giving 2D. You know, it is a multi-step reaction and they are asking you to find this reaction's enthalpy. Okay, standard enthalpy they are asking you to find out, right? And how do you find out? What information will be given in a question? You have to understand that. See, when there is a multi-step reaction and they are asking you to find its enthalpy change, you know, definitely they would have given the steps involved, okay, to form this product. So this reaction is actually taking place in two steps. So step number 1 is A is reacting with 2B to give C. So you are getting C as some intermediate, and later that C is undergoing some change to give 2D. A plus 2B is not directly reacting to give 2D. A plus 2B reacted to give C, then that C has undergone some change to give 2D. Okay, so this is how the reaction took place in two different steps, right? And now they will give these two individual reactions, okay, by which the final product has formed, right? So their enthalpies also they will give. Imagine this reaction's enthalpy is X and this reaction's enthalpy is X1. Okay, so the value, some digit, some numerical value they will give for individual steps. And now what you have to think is, you should think whether if I add these two reactions, do I get my desired reaction or what? Okay, see now on adding these two reactions, let us see whether I get my desired reaction or not. See here, the things which are there in opposite side will always get cancelled in thermochemistry, in thermochemical reactions. So now I'll cancel this C with this. So what is left out? In the left side, left out is A plus 2B. Right side, the left out is 2D. Yes, on adding these two reactions, I am getting this. That you have to check always. This is the given information. This is given, this is given. Sometimes the desired equation, the equation for which you are supposed to calculate enthalpy may be given, may not be given. With the given information you will have to write. They say it's a combustion of this, formation of this. If the reaction is given, okay. If not given, first you have to write. Okay, but in the given information these individual reactions would be there. You have to frame whether on adding these things do I get my desired equation or not. Suppose if you are getting your desired equation as it is, when you add the given equation, then how do you calculate the final enthalpy? On adding you are getting your desired equation means add the enthalpies. So imagine if the enthalpy change of reaction is some Y. So what is Y here? Y is equal to X plus X1. Okay, so just add the enthalpies of the given equation to get the enthalpy of a final equation. Okay, but the question cannot be this much simple. Okay, say instead of these reactions giving like this, they would give like this. See here, A plus 2B giving C, okay, 2D giving C. Look at here, this is equation 1 they say, this is equation 2 they say, and they'll ask you to calculate the enthalpy change of this reaction. So here, you know, its enthalpy, let us say X. Here the enthalpy, let us say X1. So how do you get value of Y here? Okay, see A plus 2B, it is on the reactant side. Okay, reactant side what is there? A plus 2B. Okay, so its enthalpy you will take as it is, X value. If it is minus X given, so minus X you will take as it is. But now look at here, 2D is supposed to there in the product side, but 2D involving reaction you check, 2D is there in a reactant side, but we want 2D in the product side in our desired equation, right? So what you will do, you're not supposed to take plus x1, you know, here in the given information it is plus x1, you have to reverse this equation, only then when you add you get this, isn't it? So when you are supposed to reverse the equation, the enthalpy value, if it is plus it becomes minus, if it is minus it becomes plus. So you are supposed to take not plus x1, you are supposed to take minus x1. Okay, so when you do this, you will get the value of y. Okay, so all these things you have to be aware of. Okay, sometimes you are supposed to reverse, sometimes you are supposed to multiply with some digit, only then you will get a desired equation. So whatever the reversing, multiplying that you are supposed to do with the equation, those things you have to do with the given enthalpy values also. And add the given equation's enthalpy by making a suitable changes that you can add to get desired equation. You know, those enthalpies you take, add, and you will get the desired equation's enthalpy. Okay, so this is the basis, okay, for Hess Law to solve the competitive questions. So now when we solve question by question, you will get more idea. See, this concept, when you practice more questions, you will understand, and your speed of calculation also increases. Your logical way of thinking with respect to a question also increases only with the practice, guys. Okay, so now let me solve the questions that I shared in the PDF document. All the questions on Hess Law I will solve. So just observe how I am approaching and solving those questions. You can also approach that way and solve the questions easily, right? So let us start with the question number 2 first. See guys, look at the question number 2. So these are the given information. See, I have not mentioned physical states, kilojoule per mole and all, just the major numbers I have mentioned. You know, this is equation 1 I can say, this is equation 2 I can say. So this is the given information, and this is the reaction for which enthalpy they are asking. Okay, so this is the reaction for which enthalpy they are asking. Okay, see, if it is a board point of view, you have to think of any changes that you have to make. In case if you have to reverse the reaction, you write, and then, you know, step by step the process you have to do. But we are discussing here the competitive point of view. So step by step process writing and all that is a time waste in the exam. Just to follow this clue, guys, which helps you a lot. Any Hess Law question you can solve easily. Okay, fine. So after listening to this video, please do share your opinion about Hess Law problems, whether now you feel it easy or not. Okay, fine. See, just you have to observe your desired equation, guys, that you carefully should observe. Okay, see, what is there in a reactant side, what fellows are there in a product side, this is what you should observe. Okay, so now in the reactant side, look at here, carbon is there. Okay, so in the given equation, in which reaction you have carbon? In the second equation you have carbon, right? So how many carbons you need here for the desired equation? 3 carbons. So what I will do, and this carbon is there in the reactant side only, so no need to worry. Take its value as it is here. What is its value? Minus 110. That value you are multiplying with 3. Okay, see, you just compare and see what changes you have to do with this value. Okay, so carbon is there in equation 1, it is there in a reactant side. In the desired reaction also it is there in a reactant side. So I took its value as it is. But in the desired equation, beside carbon you have 3. So for this equation's value you have to multiply with 3. That's it, guys. Now which is the another reactant? Okay, plus. Right, so this value plus, you go on adding the given enthalpies, that is the target. Whatever changes you have to do, that changes you do by looking at the desired equation. Whether you want to multiply with any number, or you have to write the minus sign plus or plus sign minus, so that you look at their position and write it. Okay, fine. So now over, carbon's work is over. Now Fe2O3 is there. Okay, so in the given equation, where is Fe2O3? See, in the equation 1, you have Fe2O3. Very good. That means you have to take this value here for the addition. We are only addition. We are doing addition with some numbers. Okay, so equation 1 Fe2O3 is involved, so I am taking this number. But do I take this number as it is, minus 822? No. Look at the position now. Okay, Fe2O3 in the desired equation you have in the reactant side, but here in the given equation you have in the product side. Okay, you want Fe2O3 this side. So what you will do? You are taking this number 822 but not as minus 822. You are taking it as plus 822. Okay, hope you understood why I did not take minus 822 here as it is. I took plus 822. Okay, so why? Because Fe2O3 in my desired reaction it is there in a reactant side, but in the given equation it is given in a product. So I have to write this reaction ulta, right? So when I reverse this reaction, this sign also would become reverse. So that is the reason I took plus 822. That's it. You are adding these two. Now, okay, now Fe, right? So Fe is also Fe in the given equation. Where is Fe? Here. I already considered this value here. So again, you no need to write that value once again as 822. Okay, see, and another product is CO. CO, where is it? In the second equation. Did I consider this value already? Yes, already this value is there. So again, you no need to add those values. Right? So over, guys. So what you have to do here, right? So 0, 3, 3 minus 3, 3, 3 plus 822 you have to do. That's it. So what is your answer? Plus 492 kilojoule per mole. See here, it is a matter of 30 seconds here. Right? So only carefully you have to observe your desired reaction given equation. Okay, desired reaction, carbon is there. Okay, in which of the given reaction carbon is there? Okay, here it is. So I need to take this value. Should I multiply with any number? Yes, I should, because 3 is there. Here 1 is there. So I need to multiply with 3. Now the next reactant Fe2O3. Which equation it is there? Equation 1. So I need to take this value. Should I take that value as it is, or should I multiply, or should I reverse the sign and take? This thinking should come. Okay, oh, I should reverse the sign and take. Why? Because Fe2O3 I want in the reactant side, but in the given equation it is there in the product side. So I am not supposed to take it as minus 822. I am supposed to take it as plus 822 over. Okay, don't worry about product, because Fe is there in the first equation. This value is already taken. One more time, don't take. Okay, and CO is there in a second equation. Second equation's value already I have taken. Again, don't take. Okay, if that CO is not there in equation, then some other information if they have given, then you have to consider looking at the position. Okay, so that's it, guys. So this is the simplest way of solving a Hess Law question. Okay, so now keeping this trick in our mind, let us work with question number 6 here. Okay, yeah, let me check it once again whether this is a question number. Yes, so I am working with question number 6. So this is a question number 6. This was the question number 2 in a document. Okay, guys, look at here. They have given 3 equations. You know, this is equation number 1, this is equation number 2, and this is equation number 3. And this is our desired equation here. This reaction's enthalpy they are asking, but not for 1 mole. They are asking for 2 moles here. Okay, so first we will calculate for 1 mole. See, whatever the answer you are getting, no, on adding the enthalpies of given equation, that you are getting for 1 mole. Okay, actually this is a combustion of benzene. You can only, looking at the reaction only you can understand. C6H6 reacting with O2, that means combustion. See, 1 mole of combustion reactions equation they gave. So somehow you have to make the changes with these numbers. You should add to get the answer for this equation, right? you are calculating for actually 1 mole of benzene combustion, but in a question guys they are asking for 2 mole. See, the standard enthalpy of combustion of 2 mole of benzene is x kilojoule. What is that x? Okay, so this is what they are. First we'll calculate for 1 mole, then that answer, whatever answer you get, that you multiply with 2 and that is the final answer. Okay, see, fine. So let us apply the logic here. See here, C6H6, in my desired equation, C6H6 is there in the reactant side. Okay, now check in the given equation, where is C6H6, where is C6H6? Yes, equation 1 has got C6H6, right? And this value I am taking 48.5. But do I take it as plus 48.5 or should I take it as minus? That you should think. See, in my desired equation C6H6 is there in a reactant side, but in the given equation it is there in a product side. So in that case it is not there on same side, no. So reverse the sign. This is plus 48.5, so I am taking it as minus 48.5. Okay, plus I'll go for the next reactant. If it is oxygen, they won't give anything. Forget about oxygen. If it is oxygen, you forget. Okay, next, okay, products I will say. I'll go on adding all the things. That's it. Okay, so now carbon dioxide information I should take and add. Okay, so carbon dioxide, where carbon dioxide is there in a given equation? Equation 2 has got carbon dioxide. And is the position of carbon dioxide same in the given equation and the desired equation? Yes, carbon dioxide in the given equation is in product side, and in the desired equation also it is there in a product side. But see, in the desired equation 6 is there, but here 1 is there. So what I should do? 6 into this value. So I am taking this value as it is, minus 393.5 guys. Yes or no? Same value with the sign I took as it is. Why? Because the position is same. Product side, product side. But why did I multiply with 6 here? Because in my desired equation, I have a coefficient 6 beside carbon dioxide. Don't forget to multiply. That's very important. Okay, so carbon dioxide's over. Plus one more, what is there? Water. Okay, so where is water in the given reaction? In the equation 3. Position you check first. Water is in product side, here also water is in product side. So I will take the same number, okay, minus 286. Should I multiply with any number? Yes, I need to multiply with 3, because in the given equation it is 1 mole, here it is 3 moles. So 3. So just you are adding minus 48.5, 6 into 393.5 plus minus 286 into 3. So when you do this, carefully you have to just add guys. You should not again mess up with positive, negative things and all. Okay, so carefully you should add, and I have already calculated, so I am giving a final answer here. So you will get around, I'll get minus 3267 kilojoules as answer, and this is for 1 mole yeah. But in a question they are asking for 2 moles, no? So what I should do? Minus 3267 I should multiply by 2, and that is your answer. Okay, so that many kilojoules is your answer here. Okay, see what we have done. Every molecule involving equations enthalpy we just added. That's it. Okay, making some changes wherever your number is there, that number we multiplied with, isn't it? So this is how you have to do Hess Law questions. Guys, learning conceptually is very, very important for any competitive exam. That conceptual approach I have got in the course, and the courses are very, very, very reasonable. Okay, it's a matter of spending your money for Sunday lunch. Okay, I mean to say the cost of the course is equal to one Sunday lunch or one dress that you purchase outside. Okay, so can't you sacrifice one dress? Can't you sacrifice one Sunday lunch? Yes, so invest. Instead of spending lakhs of rupees to the coaching industries, you know, invest this much and come into the course and experience the real beauty of learning. Okay, so I don't want you all to miss miss out this course, click the link below which is given. Through the link, if you come up, you will have amazing offers in the course. Just enjoy every video along with the notes that is provided. Okay, so hope I will see you all into the course. You'll have a beautiful community where the students put forward different questions and I answering to them, or your friends itself answering to them. You know, that peer-to-peer interaction is amazing in the community. So just don't think too much. Come into the course, make your learning more easier. Okay, don't get stressed out. Just click the link below and come into my community. After coming to my community, in the community section, I want a message from you all. Okay, so thank you so much. Hope I will see you all into my community.